Hey everybody, this is Larry. This is day 10 of the September Leetcode Day Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's problem. I'm still in London for another about hour, so hopefully I have a train to catch to go to Belgium. So hopefully we'll catch that train. So hopefully this problem will be okay. But yeah, so it's 6 a.m. I'm still waking up. Hope everyone's doing all right. Hope everyone's having a good week and I guess Saturday. So good weekend coming up and all that stuff. So let's get started. And is this the best time to buy and sell stock for 188? Which one is this? Let's see. So you're given integer prices, and prices is the price of a given stock on the ith day, and integer k. Find the maximum profit. Okay, and you could do at most k transactions where k is 100. Well, less than 100 or so. Okay. Oh, and n is only 1,000. So we can definitely do some n times k pseudo polynomial type thing. I think that's the way that I would try to kick it off, because that's only like 100,000, right? So yeah, let's do that. So the way that I would think about it is just the way that I started about thinking about these things are states, right? And this is going to be, for me anyway, dynamic programming. Yeah, this is going to be dynamic programming. You have to think about states, and you have to think about I guess there's the other way of doing it with but yeah, I think dynamic programming and states is the way that I think about it. The way that I think about this particular problem, and I think there are a couple of things that people do. I think the common thing is just having this recursive function, and then you put all the states down. But there's an actually, and what I mean by that is maybe you have something like max profit, and maybe I'm jumping ahead a little bit, but this is a hard problem, so maybe some of the prerequisites will be maybe doing the earlier this is the fourth one, maybe do the other three or so, because I think they're very similar. But yeah, the way that I would maybe think about it is like, so index, and this is like, so index k left and maybe status or something, right? So what does that mean? Index is just 0 to n, meaning the day that we're currently at, or something like this. K left is just how many traits we have left, which is k, right? And then status is can we buy or not. So that's something that you can definitely do for sure. But one thing that I've been trying to think is a little bit easier to teach is just maybe and it's a kind of an intro, if you will, of thinking about it in terms of different functions, right? I don't in this particular case, I think there's a lot of symmetry, so maybe you don't need it per se. But the way that I do think about it is that, okay, instead of this, we just have, like, okay, so we start off saying that we can buy a stock, right? Something like that. And then here the state is that we can buy. Let's find the best day to it's today, and we want to buy a stock. What's the most profit we can make, right? So that's the question that we want to answer instead. Then here we can just be like, oh, okay, then in that case, let's first of all set n is equal to the length of prices. We go if index is equal to n, and we return 0 because there's no money left, even if you just ooh, excuse me. Excuse me. But yeah, so if index is equal to n, then we return nothing because you didn't make any profit. no matter how many k left is there. So if k left is equal to, or if it's greater than 0, then that means that we can buy a stock. So let's say we bought it today. So then here we go, best buying today, maybe it's equal to now. Let's say then we want to sell in the future day. So then we go sell index plus 1, k left minus 1, minus prices of index. So this formula is very critical to understanding. This is what in dynamic programming they call transition, right? So this is transition. What does this mean in English though, right? I think with a lot of these problems, you obviously in your native language, so it doesn't have to be English per se. But for me, my native language is English, and in that case, how would I express, to be precise what I want to do, right? And how you end up doing that in this problem maybe it doesn't come up that interestingly, but for some problems it's very easy to get off by once if you're not very precise of how you define what your function is trying to do, or your line of code is trying to do, and so forth. So yeah, so in here we're just saying, okay, what does this mean, right? This means, and we get to define it really. So if we define it in a good way, we can actually, like you can imagine, that some of these things, like maybe you could decrement k left when you sell one instead of buying one. That's fine as long as you're internally consistent with all these things, right? So there's a lot of, so these things are these inputs and outputs are particular to how you define the problem. I think that's, for example here, then now let's say we have a sell index k left, then here it's today, right? And then instead of buy a stock though, you want to sell a stock. It's today, we own a stock and we want to sell a stock. What's the most profit we can make, right? So that's basically the idea. And the negative prices is just, when you pay for something, your account goes down. And I would say one thing that is implicit in this is that addition, and in this case subtraction, is linear, right? What I mean by that is that what I mean by that is, and also that it is whatchamacallit, commutative. Yeah, sorry, it's 6 a.m. And I'm explaining these lives. But yeah, addition and subtraction is adding the negative number is commutative. And what I mean by that is that a plus b is equal to b plus a, right? Maybe I used the wrong word, and in that case, that's why the ordering doesn't matter. That's why if you have problems where you have to like multiply something with some constant or something that's weird and it's non-linear, then you can't really do, you can't really break them apart, because the function depends on the components, right? In this case, it's fine. Anyway, so yeah, so then now this is if best not buying today. So if we're not buying today, then maybe we buy tomorrow. That's as simple as that. Okay, left. And then now we return max of best buying today. And sorry, that's my alarm. That's my my second. Oh, you gotta start heading to the train station alarm. But yeah, okay. So now selling. Again, we try to express this in English. This makes the problem more tractable for us. And then we go, okay, so if this is the end of the day, we still return 0. We hold the stock for no reason. So yeah, but otherwise we go best selling today. If we sell, then we can buy again in the future. So we go but then now we make the money for today. And then best not selling today is then we could sell it maybe tomorrow, right? So something like that. And then again we take the max, because locally optimal. Okay, and then at the very end we return buy of 0 and k on the 0th day and the k, and that's pretty much it. I mean, I know that this is not it in the sense that we have to do the memorization, but conceptually that's it, right? Did I have a typo? Best buying today, best not buying today. What did I best buying today? Isn't it? Oh, I see. That's right. Okay, so this is good. Of course, if we, if you, I guess let me just have a. However, it's really easy to time out is what I was going to say. So yeah, that's probably not 1,000 yet, right? But it'll probably be good enough to time out. So it's going to time out. Hopefully, well, it's one of those. I would say, yeah. If it doesn't time out, then I have to reevaluate. Your understanding, right? Is of the problem. I mean, sometimes I mean, it's still slightly better that you get it right by accident than not, but still, part of testing isn't just solving a problem per se. It's or having your whatever match is that it matches your expectation, right? Meaning that if you expect it to be correct for a certain input, it should be correct, and if you expect it to be not correct for a certain input, it should also be not correct, right? And if it's correct by accident, then you're like, maybe some of the assumptions are wrong, right? And maybe that's fine, but in any case, yeah. So time limit exceeded. Now with that memorization, I want to say that before I get started a little bit. Let me try to find my thingy. I do have a dynamic programming progression video that I think I don't remember what my example problem is, but definitely check that out. So basically in that video I go from so I have it here. If you search for, can you see this? Yeah. If you search for Larry explains whatever, then it'll pop up hopefully. But yeah, but I don't remember the progression I use for this one. But the same idea is that going from here to more space efficient and to more bottoms up instead of tops down. If you want to practice that, I definitely advocate practicing both in a good practice. I like teaching with tops down, but honestly, when I'm by myself, or like when I'm actually in contest mode, I do bottoms up and tops down way, very interchangeably, and depending on how I feel about the problem. Sometimes I'm wrong too, even. There are some trade-offs I'm not going to go over here, but check out that video if you're struggling a little bit with progressing beyond the basic top-down dynamic programming. But yeah, the short story here is that we go, okay, the idea behind memorization, and this is why it's called memorization, is that and that it applies more than just in a dynamic programming context. The idea behind memorization is that for every given input, you get the same output. Basically, f of x is always going to be y every time, right? There's no mutable state or something like that, because there are cases where maybe if you pass in the same variable, like maybe time is an input, right? Like like if you have a function that's like, oh, what's the temperature now, for example, maybe that's a bad example, but if you have an example that's like, oh, what's the temperature now, and then it could be like 30 degrees, and then in 5 minutes it could be 35 degrees or something, I don't know, right? And then that's obviously you can cache that. I mean, you can actually, for maybe that's a system design question for something else, but anyway, okay, my point is that excuse me. Excuse me. But yeah, my point is that for every input you have the same output. So therefore you can do maybe some, then you check if you've done the input before, and also yeah, that's pretty much it really. And then return the same thing if you've seen it again. So that's basically the idea. Let's see, what's it? Something like that. Right, and then here we can I will do this one for now, and then you say, okay, if we have cash for this one, then you return it from the cache because you're like, okay, we've seen it before. Otherwise, if I can type correctly, then we set the cache up so that in the future we can reuse it. Yeah, so now what is the complexity, right? Well, we only make 2 calls, so everything else is O of 1 because everything is a lookup. So as I always say for DP, and this is something that people ask me a lot, and I keep on explaining in the same way, but maybe people are not just watching the video, I don't know, whatever. But the total time is just, this is a pretty basic thing, and for most problems it's pretty okay. At least most basic problems. Sure, some problems there's some amortization and stuff like this that averages things out, but for this particular part, total time is just time per input times number of input, right? This is, maybe if you write it out, it makes sense, right? You have, this is like miles per hour over times the number of hours, for example, will give you, how much miles you go. So time is totally like that. And then time per or number of input is just n times k, right? Because for index you have 0 to n, and for k left we have k, right? 0 to k. So this is the number of input, all of these, and each input takes all of 1 time. So total time is O of n times k, right? Similarly for space, each input takes O of 1 space, so total space is O of n times k. Of course, this assumes that the cell is also cached, which we should, so let's do it. So yeah, that's basically the idea. I don't know if I think today I'm explaining things a little bit not as good, to be honest, but I really gotta catch my train. Actually, this has already been 17 minutes. Okay, fine. But yeah, let me know what you think. The analysis for the cell part is. I'm trying to also remember to remember to submit it this time, so give me a second. But yeah, let me know what you think. Maybe today's a little bit iffy, and these 6 a.m. videos are very tough on me, so I apologize. Because I'm like not awake, to be frank. But this is also why I do so poorly on the bi-weeklies, maybe. But yeah. Cool. Alright, let's run it again. Hopefully this time it should not let's have a typo. Yeah, see, even for the big case it runs really quickly. So let's give it a submit. Wow. How did I get so many? Hopefully this, oh man. Not gonna lie, I was a little bit 890-day 3 streak, yes. I was a little afraid that I was wrong and then I have to spend a lot more time explaining, or at least solving and then explaining. What was going on here last time I did this? Huh. Let's see. Oh, I think I was doing it the other way with the stack and rally, which I'm not gonna go over today, but it is much faster for, yeah, but today we did it with DP, so we'll go with the other way of doing it when it comes up more. Oops. But yeah, so this is my code. That's all I have for this one. I gotta run, so hopefully you hopefully you did well. But yeah, I'll see y'all later. Stay good, stay healthy, take good mental health. Goodbye and take care. Bye bye.